Dr. BLT here, and I am also known as Dr. Bruce L. Thiessen, psychologist, clinical psychologist, and singer-songwriter. Rapid-fire singer-songwriter of multiple genres. I'm here to talk about the eye and how studying the eye can lead to cognitive overload. Baby, your eyes are naked. You're sharing all your secrets deep inside. Baby, your eyes are naked. There's no place for love to hide. Okay, I'm not going to finish that song because I have a lecture to do here. But that is an original song called Naked Eyes, and I just wanted it to be the music that leads into our discussion today of the eye and how studying the eye can interfere with an efficient cognitive processing. So I'm going to put my guitar back and I'll be back to talk more about the subject. I'm going to talk about cognitive overload as I'm sitting here on the swing. And I have some wires behind me, and those are to represent the neural networks within the brain. But so I was young, I wanted to become a psychologist. I was all excited. I took my first intro to psychology class. And this is what I got. We were studying the eye. We were studying visual perception. I'm reading from Mark Ashcroft, his book called Cognition in the 4th edition. And I'm reading this to give you a sense of how complex the eye is. First of all, he points to a particular figure, figure 3.1, illustrates the basic sensory equipment involved in human vision. Light waves enter the eye, are focused and inverted by the lens, and are projected onto the retina. Okay, at this point, the information is already beginning to sound overwhelming, so my brain is now dealing with interference, thoughts that come from my unconscious perhaps, suggesting that this is too complicated for me to pick up on, and I began to call myself names that maybe I internalized from my childhood, like I'm incompetent, or I'll never be good enough to learn important information that will propel me in my ambitions. It goes on from there. The retinal surface is composed of 3 basic layers of neurons, rods and cones. Now there's something about rods and cones that just stays in my mind, but everything else I've read, it seems like it's just a blur at this point. Axons, rods and cones are axons of ganglion cells, and they converge at the rear of the eye, forming a bundle known as the optic nerve. This nerve exits the eye and continues back through various structures in the optic system. For example, the optic chiasm, the junction of the optic nerve from each eye, eventually projecting the neural message onto the visual cortex of the occipital lobe in the lower rear portion of the brain. Now, by this time, I'm completely lost, and my mind is dealing with competition. This has to do with attention and my inability to focus. And this is due to cognitive overload because the eye is so damn complex. Okay, then the author goes on. A brief explanation is in order about how the eyes transmit visual information to the brain. The principle of contra contralaterality in vision is not as simple as left to eye hemisphere as you might have expected. So already the author is warning that there's more complexity ahead. So, what is happening here? My sympathetic nervous system has kicked in. I begin to possibly sweat profusely. My heart rate goes up. My breathing is not as fluid as it once was. And I feel tense. I believe that I'm already overexposed to too much incoming data. And now I face the prospect of even more complexity. So, the principle of contralaterality in vision is not as simple as left eye to right hemisphere, as you might have expected. Instead, each eye transmits visual information to the occipital lobes of both hemispheres in the brain, to the region known as the visual cortex. In particular, each half of the retina picks up on visual information from the contralateral visual field. So you can imagine how I felt, all excited. I wanted to become a psychologist. I wanted to help people. And now I was being exposed to such detailed, mechanical information of such complexity that it was messing with my mind. As illustrated in Figure 3.2, if you focus straight ahead on a fixation point, the left half of each eye receives images from the right visual field, the house, and the right half of each receives images from the left visual field, the tree. All the information from the right visual field. The solid lines in the figure is first registered by the left half of the retina and is then transmitted to the left hemisphere of the brain. Likewise, stimuli in the left visual field, the dotted lines, are projected to the contralateral right half of the retina, then sent to the right hemisphere. Thus, the contralaterality in vision is between the visual field and the initial hemisphere, left visual field to right hemisphere, right visual field to left hemisphere. And at this point, I am feeling frustrated. I am feeling anxious. And I am beginning to arrive at something that Seligman called learned helplessness and a feeling of hopelessness. I'm never going to be able to figure this out. So he goes on, the split brain patients described in Chapter 2 were prevented from seeing their hands because each eye transmits information to both hemispheres. The purpose of the tests was to see what each hemisphere could do by itself, which would have been thwarted if the patients had also seen the object. So once again, I've been given more information and I'm already overloaded. All I remember from all of this is rods and cones, rods and cones. For some reason, those are simple words that just stand out, but the rest of it is a blur because of cognitive competition. And that has to do with attention and perception. It goes on to become even more complex. Of special interest in this quick physiology lesson is the idea of compression, a kind of transformation that both analyzes and summarizes the visual input. That is, the message that finally reaches the visual cortex represents an already processed and summarized record of the original stimulus. As Haber and Hershenson 1973 pointed out, only a fraction of the original light energy is registered on the retina. The rest is absorbed and scattered by the fluid and the structures within the eye. Furthermore, the three-layered retina also loses information. There are approximately 120 million rods in each retina and about 7 million cones. Most of the cones lie in the small area known as the fovea, or the foveal pit, which provides us with our most accurate, precise vision. At least some of the cones in the fovea seem to have their own private bipolar cells for relaying impulses. Oh, by this point I'm just exhausted. I'm feeling frustrated. I'm feeling overwhelmed. The parasympathetic nervous system has drifted far away. I want it to come and rescue me, but the sympathetic nervous system has taken over. One cone connects with one bipolar cell instead of many cones funneling their information into one bipolar cell. Technically, a cone synapses onto a bipolar cell. This is not the case in peripheral vision, however. About 20 degrees away from the fovea, tens or even hundreds of rods in the periphery converge on a single bipolar cell. All right, that's enough. So at this point, I'm completely discouraged. What you see going on here has to do with attention, our ability to focus, and our ability to efficiently digest information. When we have something known as information overload, it reminds me of a Police song called Too Much Information. That's another song that comes to mind by the Police. But some people are so brilliant in terms of a particular area of the brain that processes detailed information that this is not a problem. But since I'm basically known as a right-brained individual, musically inclined, and I'm into the big picture, the forest, I tend to miss the trees. And you might have that same experience. But when you do, remember, you are not alone. Even your psychology professor, Dr. BLT, even with his great skill in writing 3-minute songs in the course of 2 minutes on demand, even he, that's me, Dr. BLT, struggles with information overload. Thank you for listening to my lecture and for listening to my song Naked Eyes, and have a wonderful day. I'm Dr. BLT.